Hello, this video is part 2 of graphing absolute value functions. I have written out the formula and the steps for your convenience. You can also find it in the graphing absolute value functions intro video. So we'll start by finding the axis of symmetry. The axis of symmetry is found by looking at that part, and whatever the opposite of that is would be the axis of symmetry. In this case we have a -3, therefore the opposite would be x equals +3. That +3 is also the x value of the vertex. Now in order to find the y value of the vertex, we have to look at k, which for our problem is 5. That takes care of step 1 and step 2. For step 3, we have to pick 3 numbers to each side of that axis of symmetry. Let me start by graphing the vertex. So that would be a 1, 2, 3. So this right here would be the vertex. Now it's important to look that if you have a number here that is positive, this means that our graph will be opening up. Whenever that number is a negative, it opens down. Now let's pick the points. We have to pick points close to the axis of symmetry, which would be 4, 5, and 6, and to the opposite side would be 2, 1, and 0. Now we will be using those points to plug into the original formula, evaluate, and get the value of the y-coordinate of all the points. I'll start off by writing out this entire formula down here and then evaluating. So we have y equals 2, absolute value, x minus 3, close the absolute value, plus 5. So I left a blank right there because that's the only thing that will be changing in our problem. We will start with plugging in 0. So if I plug 0 in here and then evaluate, we get what follows. This would be equal to 2, absolute value, 0 minus 3 is -3, plus 5. Now, whenever you start evaluating absolute values, anything inside the absolute value is a positive. Therefore, this is the same thing as multiplying 2 times 3, which would give us 6 plus the 5, and that would be 11 for 0. You would repeat the process for the other numbers. Now I will plug in a 1. Everything else that I left there will continue to be the same. So inside the parentheses we have 1 minus 3, which is 2. 2 times 2 is 4. And when added with the 5 would give us 9. Same for whenever we use 2. Now I'll plug in 2. 2 minus 3 inside the absolute value is -1. When I multiply, remember this is positive, so 2 times +1 is 2, plus the 5 would be 7. You are welcome to do it for the other numbers as well, or you can just reflect the points. Let me start by graphing the top 3. We have 0, 11 goes off the graph, 1, 9 right here, 2, 7 would be right there. So we have half of the graph. Now, this right here is the axis of symmetry. And therefore, whenever you graph the v, it would be equal on both sides. That lets you know that if that number right there is 7, then the one right here would also be 7. If this is 9, then this also would be 9, and the last one would be 11. Therefore, when we graph, the points would be right there, and we have a mirror image of the graph. Now all you have to do is connect the points with the straight line. And since this is a continuous function, put the arrows to denote that it keeps going forever.